You're welcome to the second session. We are recording a video about the techniques of integration. This is chapter 1, Pure Mathematics, book 2 by Backhouse. This is our reference book. The second technique of integration we are looking at is how to integrate the even powers of the cos x and the sin x. We have to recall Pythagoras' theorem, where we can make sine square the subject and cos square the subject. So it's pretty easy. If we're asked to integrate, for example, the sine to the power 3 of x, we shall express this as the sine squared of x times the sine of x dx. You might want to recall that previously we have already looked at identifying a function and a derivative. So the reason why we are having a sine square here is so as to replace the sine square with the cos square, such that it looks like 1 minus cos square x sine x dx, which will therefore become something nice, sine x minus cos x sine x dx. This cos here is raised to the power 2. We can easily integrate sine x dx, but the problem would be on the cos square x times the sine x dx. So that's why it is important that you watch the first video where we are identifying the function and the derivative, such that you are able to see that the cos square, the cos is a function. If I differentiate cos, I get sine. So someone who differentiated cos to the power 3 got 3 cos square x sine x. I think the other video will help you. So this one should become the other function that people differentiated earlier, which was cos cubed x, and then divide by the new power 3 plus a constant. So here you integrate sine x and get negative cosine of x, I think so. So this should be your answer. Another odd power is the cos to the power 5 of x. We have looked at the sine, so let's look at the cos and let's increase the power. So the cos to the power 5 of x, we would think about it as cos to the power 4 of x times cos x. That's how we would think about it. So cos to the power 4 of x, we don't have an identity for cos to the power 4, but we have an identity for cos squared. That's why we shall have cos squared of x then squared. You multiply these two powers, you come up with 4. So the cos squared of x is 1 minus sine x. The cos squared of x, we have here cos x into 1 minus sine square of x, everything squared. So this is a cos square of x. So if you open that bracket, 1 minus sine square x squared is 1 minus 2 sine square x sine power 4x. Sine power 4x, exactly. So open the bracket, you get a cos x. Now you multiply here, you get 2 sine square x cos x, the negative comes out. Sine power 4x cos x. And then we can start identifying functions and their derivatives. That's why it's very nice that if you have not watched the original video, please go back and see how it goes. So this should be sine x, as simple, fair enough, sine x. This should be someone differentiated cos x. Someone differentiated the cos x. Fair enough. So you have 2 sine cubed x over 3. Someone differentiated sine power 4, sine power 5. So you have sine power 4 x, sine power 5x, over 5 plus a constant. This reminds me that the other one up, exactly. The other one up, where someone differentiated the cos cubed of x to get cos square x sine x. When you differentiate the cos cube of x, you're going to get 3 cos square x then times the negative of sine x. So when you are dividing here, you divide by the negative 3, and that becomes positive. So that should be it. Thanks for your time.